Hey everybody, now we're going to look at the applications of the normal distribution, section 7.2. We're going to convert values from a normal distribution to z-scores, finding the area under the normal curve, find value from a normal distribution corresponding to a given proportion. First, we're going to convert values from normal distribution to a z-score. So recall that a z-score of data value represents the number of standard deviations that the data is above or below the mean. If x is a value from a normal distribution with a mean of mu and a standard deviation of little sigma, we can convert x to a z-score by using a method known as standardization. The z-score of x will be x minus the mean all over the standard deviation. So for example, consider a woman whose height is 67 inches from a normal population with a mean of 64 inches and a standard deviation of 3 inches. The z-score would then be, x would be the 67 that we're looking at, the mean is the 64, that is the mean score of the population, and 3 is the standard deviation. When we do all of that, we will find that our z-score is actually 1. So I want to point this out a little bit more. So here we have 0, 1, 2, 3. 0, negative 1, negative 2, negative 3. It corresponds with the mean height, which was 64. See, 64 and 0 correspond. This is the z-score. This is the actual data. The z-score of 1, which means 1 standard deviation away from the mean, corresponds with 67 inches. So z-score, actual data. Finding the area under a normal curve. Well, we've already looked at this a little bit. We might use the area to the left to find the z-score when computing areas for a general normal curve. We first standardize to z-scores. So if we have our z-score here and we have our area underneath, this was our table that shows our z-value, and then this is our hundredths place of the z-value to get our area under the normal curve. So a study reported that a length of pregnancy from conception to birth is approximately normal with a mean of 272 days and a standard deviation of 9 days. What proportion of pregnancies last longer than 280 days? So the z-score for 280 would be 280 minus the 272, which is the mean, all over the standard deviation of 9. So that z-score will give us 0.89. So now what I do is I go to my z-value, 0.8, and I go over to my hundredths place, which is 9, and this will give me the area under the curve. So you need to remember that here in the table are the areas, and here are the z-values. Length of pregnancy from conception to birth is approximately normal again with a standard deviation of 272 days, standard deviation of 9. A pregnancy is considered full term if it lasts between 252 and 298. So what proportions of pregnancies are full term pregnancy? So we're going to find the upper and lower bounds using the z-score. We have from negative 2.22 to 2.89. Those are our z-values that correspond with 252 days and 298 days. We can use the table to find that the area to the left of 289 is 0.9981 and the area to the left of 2.22 is 0.0132. So between that, you would subtract these two numbers, 0.9981 minus our 0.0123, and you'll get the area of 0.9849. So the proportion of pregnancies that are full term between 252 and 298 is 0.9849. Let's find the area under the normal curve using your TI-84. Study reported that the length of pregnancy, again, same question, mu 272, standard deviation of 9. What proportion of pregnancies last longer than 280 days? Well, we can use our normal CDF command with 280 as our lower endpoint and our 1E99 as 1 and 99 zeros as our upper endpoint. And we conclude that the proportions of pregnancies that we have, again, the 272 here is our mean, our standard deviation of 9. I forgot to mention that. Once we have all four of these numbers in here, it will give us 0.187031, etc., which we will round to 4 places. Looking at our full-term pregnancy problem where we have the mean of 272, standard deviation of 9. We're looking for between 252 and 298. Okay, so we have our CDIF command. We can use our 252 as a lower, 298 as our upper, 272 as our mean, and 9 as our standard deviation. Notice we didn't have to find any z values for this. And once we put this all in, we will find out that we will get 0.9849, just like before, rounded to the 4th decimal place. Now we're going to look at finding the value from a normal distribution corresponding to a given proportion. Here we have the standardized formula. Once again, z equals x minus mu all over the standard deviation for x. The value of x corresponds to the given z-score is height in a group of men are normally a mean of 69 inches, standard deviation of 3 inches. Find the height whose z-score is 0.6. Interpret the result. So you see here, we want to solve with the height of the z-score of 0.6. So x will equal the mean plus the z-score times their standard deviation. And how did I get that? Well, if I multiply both sides by my standard deviation and then add my mean, this is how I get this formula. So once again, multiply both sides by the standard deviation, move the u to the other side by adding it, and I get u plus z times the standard deviation. So when I plug those values in, I can get my x value of 70.8. So we interpret this by saying that a man 70.8 inches tall has the height of 0.6 standard deviation above the mean. Now, the steps for finding the normal values, the following procedure can be used for that. First, you should always sketch the normal curve, label the mean, label the value of x to be found, shade in the label to the given area. If the given area is on the right, subtract 1 to get the area on the left. Look to the body of table A2 to find the area closest to the given area, find the z-score that corresponds to that, and then obtain the value of the normal distribution by computing x equals the mean plus z times the standard deviation. Now, keep in mind, z-score is how many standard deviations away from the mean. So that's why you're going to take z times the standard deviation and add it or subtract it from here to get your value. Now, Mensa is an organization whose membership is limited to people with an IQ that is in top 2% of the population. Not me, by the way. Assume that the scores on an IQ test are normally distributed with a mean of 100 and a standard deviation of 15. What is the minimum score needed to qualify for membership in Mensa? All right, so we want to find where the area is in the upper 2%, which means that's the lower 98%. So the area on the right of the 2%, we would subtract 1 from the 98% area that we find. The closest area to 0.98 in table A.2 is 0.9798, pretty darn close to 0.98. That corresponds to a z-value of 2.05. So now we're going to stick that 2.05 in for the standard deviation into this formula. In for the z-score in this formula, multiply it by the standard deviation, add it to 100, and we will see, since IQ scores generally are whole numbers, we're going to say it's about 131. Finding the value from a normal distribution corresponding to a proportion using your TI-84. Again, we have same question. Let's look at the solution. In the figure, we see that X separating the upper 2%, we have the lower 98%, the area 0.2 on the right, so we subtract 1 with the area of 0.98 on the left. Now, we can use our inverse norm command with 0.98. We're going to put 100 as the mean, 15 as the standard deviation, and when we do that, we will get the same value of 131. All right, so this was a pretty quick one. How to convert values from a normal distribution to z-scores, how to find the areas under the normal curve, how to find the value from a normal population corresponding to a given proportion. And that is the end of 7.2. I will see you soon for 7.3. Well, talk to you soon. Take care.